everyone. Today we would like to explain about the double pendulum. So double pendulum is one of the typical questions about the classical mechanics. Then by solving this equation, we would like to explain how to use the Lagrange equation. So to solve this equation, so we set this configuration. So first we put the wire on the roof. Then we assume the length of wire as L1. Then we suspend the M1, so this is the masses. And also we put the one wire here and put the M2 here. At that time, so we can explain the position of M1 and M2 as a function of phi1 and phi2. Then we can estimate the position of each masses. So to estimate the Lagrange equation, so we need to estimate the Lagrangian. Lagrangian is function of kinetic energy and the potential energy. To estimate these terms, we need to calculate the velocity and the position of y length. To estimate this value, first we describe the position of M1. Position of M1 is a function of x1 and the y1. So to estimate the length of x1 and the y1, so we can calculate a combination of L1 and phi1. Then we can describe these equations. So to estimate the velocity of these terms, so we need to calculate the differential equation. Then we can calculate the x1 dot and the y1 dot like this. So once we get the combination of these factors, so we can estimate the kinetic energy and the potential energy like this. So by inserting this equation into this formula, so we can calculate the T1 like this and the U1 like this. Okay, so this is a Lagrangian for the upper mass. So in next step, we try to estimate the lower mass. So position of lower mass is sum of x1 and this length. And the height of this mass is y1 plus this length. So first term is corresponding to the x1. And the second term is corresponding to the length from here to here. So to describe the length from here to here, we need to calculate the L2 sine phi 2. So on the other hand, y term is like this. So we calculate the y1, and we also add this factor. So this factor can be calculated with L2 cosine phi 2. So we can estimate the velocity of each term by solving the differential equation. Then we can get this term and this term. So basically, this term is corresponding to the x1 term. And also, this term is corresponding to the x2 term. We can also calculate this term. So this one is from this equation. And the second term is from this term. Then we can calculate the kinetic energy like this. So kinetic energy is combination of x velocity and the y's velocity. So by inserting this equation into formula, so we can get this term. At that time, so we can stack this term and this term. This is because cosine square plus sine square is 1. We can also calculate this square plus this square. This is because cosine square plus sine square is 1. So we can stack these terms like this. On the other hand, so by calculating the cross term with the first term and the second term, so we can calculate this term. Then we can get this factor. So this factor can be stacked with the formula of cosine. Then we can calculate the cosine formula like this. And also we can estimate the U2 with this equation. Then finally we can get a combination of T2 and U2. Okay, so finally by inserting the kinetic energy and the potential, so we can calculate the Lagrangian like this. So to get the equation of motion, so we insert this Lagrangian into the Lagrange equation like this. at that time, generalized parameter is phi 1 and phi 2. So we can solve the two types equations. In the first step, so let's try to solve the first equation. So this term is corresponding to this term. So we calculate this equation with phi 1 dot. So phi 1 dot equation is here and here. Then we calculate the equation like this. Then after that, we apply the DTD operator to here. Then we calculate each term like this. And finally, we can get this equation. In next step, we calculate the second term here. So second term is corresponding to this term and here. So we can solve this equation like this. And finally, by inserting this term and this term into the Lagrange equation, so we can calculate the equation of motion like this. So by stacking each term, so we can get this equation like this. Then finally, we can get the Lagrange equation for the parameter 1. Okay, for next step, so we try to solve the equation 2. So in the case of equation 2, so equation 2 is equation of phi 2. So by solving the first term like this, so we can calculate this equation. Then we can calculate the operator of dt for this equation. Then we can get this equation. Second term is corresponding to here. Then we can calculate this parameter. After that, we also insert this factor and this factor into this equation. Then we can get this equation. So by stacking each term, so we can get this equation. This is the equation of motion for the second equation. Finally, so we can calculate the two types equation from the phi 1 and the phi 2. Then we can get the equation of motion. Thank you for listening to the follow-up lecture.